All right, so section 4, 2.4 is about multiplying matrices. First, we're going to talk about multiplying a scalar times a matrix and then a matrix times a matrix. Now, when we're talking about scalar, that's what we call real numbers in matrices. So the question is, what is the product of a real number and a matrix? So we say the product of a matrix and a scalar. So the product of a scalar k and a matrix x is called kx, in which each element is k times the corresponding element of x. And all of that may sound complicated, but here's an example for us. So let's say we want negative 5 times a. Then what we're going to do is multiply our k, which is negative 5, times each element in matrix A to get our negative 5a. So negative 5a is equal to negative 5 times 3, negative 5 times 4, negative 5 times 0, and negative 5 times negative 1 is what that would be. The result is negative 15, negative 20, 0, and then positive 5. All right, so it's just like that. That's how we multiply. Now, when we find the product of two matrices, it's a little bit different. But once you get the hang of it, you'll be okay. So it says, let A be an m by n matrix and let B be an n by k matrix. The product can be found as long as the column of the matrix A and the row of matrix B match. So what I mean is n and n, they have to match there. If not, then we can't multiply them. All right, so let's keep going. So the product is found by finding the element in the ith row of A and the jth row of B. We multiply them and then add the products. The product matrix AB now has the size of m by k. So it has the number of rows of the first matrix and the number of columns of the second matrix. That's what happens. As always, let's do an example because I think it'll make much more sense once we have an example. So let's say we want to find the product AB. All right, so here we're given 2, 3, negative 1, 4, 2, 2. And then we're given for matrix B 1, 8, 6. Now let's pause to find the sizes for each of these matrices. We have 2 rows and 3 columns, so we would call this a 2 by 3. Matrix B has 3 rows and 1 column, so we would call it a 3 by 1. Notice the number of columns in matrix A matches the number of rows in matrix B. Therefore, we can multiply these two to get a result, and we should expect the resulting matrix to be a 2 by 1. We should expect that. All right, I'm going to rewrite this so that we know how we're going to multiply it. And I'm going to try to take it step by step. So we're multiplying by 1, 8, 6. All right, so how are we going to get started? We're going to take our first row and multiply it by the first column. So when we take the first row, first column element of the first matrix and the first row, first column element of the second matrix, we multiply, right? And then we write it to the side. So it'll look something like this, right? Where we have 2 times 1, which we know is 2. And we're going to add that to now 3 times 8, which we know is 24. And we're going to add that now to negative 1 times 6, which we know is negative 6. That's how this goes. And we're done because we are at the last elements, the last element in the row and the last element of the column. So now that's the first row, first column, and we have that right here. So now from here, what we want to do is we want to take the second row and multiply it by each element in this column. So each element in the row times each element of the column, and we write it here. So that'll be 4 times 1, which we know is 4, and then plus 2 times 8, which we know is 16, plus 2 times 6, which we know is 12. And so now for our result, we have 20 and 32, and it is a 2 by 1. We're done. All right, it does get a little bit more complicated as you go, but the main thing is still the same. You have to have the column of the first matrix to match the row of the second matrix. So let's say for another example, we want to find the product CD of the matrices. So we have that C is negative 3, 5, 4, 0, 2, 4. And then for D, we have the following. So let's go ahead and find our size. We have 2 rows and 3 columns. Here we have 3 rows and 2 columns. Since these inner numbers match, we can find the product. And so how this will go, I like to write them side by side like that to show the multiplication. And what we're going to do is take our first row times our first column. And so we're expecting a 2 by 2. So we take negative 3 times negative 6. So we start here. That gives us a positive 18. Plus then 4 times 3, which is 12. Plus 2 times, oh shoot, I'm on the wrong. Lord have mercy. Sorry, people. I might have got you confused. I apologize. But what happens is we're going to take 4 times 2, which gives us 8. And then we're going to take 2 times 3, which gives us 6. And we're done with that particular part. Now we can take this first row here times the second column. So that'll be negative 3 times 4, which we know to be negative 12, plus 4 times 3, which is positive 12, plus 2 times negative 2, which is negative 4. So we're done with this first row of the first matrix, right? And now we're going to second row, first column. So 5 times negative 6 would give us a negative 30, plus 0 times 2, which is 0, 4 times 3, which is 12, and we are adding. And then finally, we're taking the second row times the second column, which will give us what we need here. 5 times 4 is 20. 0 times 3 is 0. And 4 times negative 2 is negative 8. So finally, our result should be 32, negative 18, negative 4, 12. This is the result. All right. I think that's it.